share my screen and we'll get started. All right, does this look right to you, exercise 3?
Yes.
Okay, there exists a closed economy with an output target, YN, income 1 million, tax rate is 25%. There are no transfers besides unemployment benefits, and the unemployment benefit and transfer rate U is 15%. Government spending is 2,500. The investment function is I equals 200 minus 20R. Consumption function is 750 plus 0.5 YD, where D is disposable income. What is the equilibrium level of output as a function of R? Okay, so there's a formula for disposable income. Disposable income is Y minus T, so taxes, plus transfers, but then it says this comma dot dot dot, so I guess there's more to it. Not sure I completely remember that from last time, but maybe like the transfers were between, I think transfers were between Social Security and unemployment benefits. Let me go back and look.
Yes.
That seems, but that was from a different assignment.
That would be like, we would include the rate.
Yeah, I mean, yes, I mean, and it's that is part of the transfer payments here.
Okay.
But the output, let me see here, let me speak. So we need to get a formula for C, and then I believe you're setting it equal to, or you're going to use it with I and G. So okay, actually let's back up here. So this is that's for disposable income. There's this other formula for Y. Y is equal to C plus I plus G.
Yeah.
And I guess the idea here is that we can get a formula for I is given, G is 2,500, so that's given. C comes from this formula right here, which is based on this formula here.
Yes. Okay, got it. So
we
basically, we're given enough to where then we can solve for Y using like YD.
Yes, but what's odd here is Y appears twice, which I don't really understand, but maybe maybe that'll come out of this. But okay, so Y, so yeah, I mean, I don't, maybe they mean different things here, not sure, but okay, let's go with C. So to start with, C is 750 plus 0.5 times YD, which is Y minus T plus TR. So we've already, we're substituting that in. Now Y is, what are we doing there? Okay, so I see what they're doing. Let's start with T.
We're solving for Y in here.
Yes, yes, that makes sense. So T is tau, the tax rate, times Y. So that's going to go in the middle there. The TR is U, which is this transfer rate, times YN minus Y. And we're going to substitute that into this equation here. So 750 plus 0.5 Y minus tau times Y plus U YN minus Y. Is that okay for the moment?
Yes.
Okay. And when you distribute this U, it's UYN minus UY. And then you're supposed to notice that there is a Y in 3 of the 4 terms.
So we can take that out, or like not take it out, but put it, factor it out.
Factor it out. So it ends up being Y times 1 minus tau minus U plus U, Y, N. Is that okay?
Y1 minus tau minus, okay, that's where the minus comes.
Okay, so those three factor out. And now you can substitute in for those values. Tau is 0.25, U is 0.15, U is 0.15, YN was given from the beginning as $1 million. Okay, so the this part inside here is 0.6y, and you're multiplying that by 0.5, so it's 0.6y plus 15, that's 150,000. You're multiplying by 0.5 and you're adding 750 to it. So you're just cutting the numbers in half. So 0.3y plus 75,000, and then you're adding 750 to it. So when you distribute that in to that inside there.
Yes.
All right, so now we finally have it. C is 75,750 plus 0.3 y. And the reason we were doing all that is because we wanted C in this equation, which we kind of had. It just was in terms of y. So now we're going back to this y equals C plus I plus G.
Okay, so then then it would be y equals 75,750 plus 0.3y plus the numbers we were given and the equation.
Yes. So I in this case is given as an equation 200 minus 20r, and then G was 2,500. These were both givens. All right, which allows you to solve this as a function of y as a function of r. Basically, you're going to get the y on one side. So that ends up being 0.7y equals, and then we can combine. So you can combine.
Is it 0.7 or 0.3? Oh, no, because you're subtracting. Never mind. Got it.
You can combine these three values, and that's, let's see here, 78 or 50. And then you got minus 20r. And then you can divide everything by 0.7. And this produces some decimals. 112,071 minus 28.57 r.
Okay, that actually was not bad. That was just like a lot of work.
Yeah. So like one of the things I think that would be worth doing here again is just maybe really knowing, okay, that's an equation, that's an equation, and maybe not redoing all the steps, but redoing enough of them to where you feel like you can reproduce this. Because it is asking for a function. It says, what is the equilibrium level of output as a function of r? They're asking for y as a function of r. We now have that.
Got it.
Okay. New question. All right, suppose that in order to stimulate the economy, the government increases its spending by $1. So government spending goes to 2501. So 2,500, G was 2,500, it goes to 2501. And the change that's made, boy, that's the change right here, this line right here.
Yes.
So I guess like, and one way to look at this is it's not just that it could be this number that changes. They could actually say, you know, any of these change, but that's That's maybe something just to think about. This number is now 2501, and then you resolve for y in the same way that we just did. So I won't go through all those steps, but it's the exact same procedure. Y ends up being 112,072.86 minus 28.57 R. Now what I don't understand is, okay, so I didn't round this one to the enough decimal places. That's where the issue is. So this one up here is 0.429. I didn't think that would matter.
Yeah.
This is 0.857. I don't know why this 857. And so the multiplier is the difference between them. That's not, but that's not. Oh, it's 72. Okay, yeah. So you take this 112,072.857 and subtract the 112,071.429. Now, why do you subtract those? I don't know. That's just what the math
Okay.
says.
Yeah.
Okay. Which equals 1.428. And it's the constant of the equation, if that matters. So the idea is that $1 increase in G causes a $1.428 increase in Y.
Increase. Okay. Yeah, that makes sense.
Okay. Part C is, it's kind of what I was referring to here, where they can also increase other things. So here they increase tax revenue by, it says to ensure there'll be no further budget deficit, the government also increased its tax revenue by $1. So we didn't have that. We had so if you go, well, this is really complicated. You're going back to the tax payment was this one right here. No,
It was
the tax rate is 25% of this number,
yes.
but they're saying like it's now only $1 less. So, but the problem I'm seeing is that they subtract 1 in the solution from the unemployment transfer. So let me show you that here. So they're subtracting 1. So this was yn, and this was u, and they're subtracting 1 from this transfer payment, which isn't what this says right here. The tax revenue I thought came from tau. Oops, that's a J. Tau times Y. I thought, so I would think it would be there, but they're not doing that. So
well, let me see what well, to increase its revenue, wouldn't it be adding a 1 or no?
that's true. Yeah, that's also, why is it so maybe it's saying it this way, that to increase its revenue, they are paying out less in transfer payments.
I don't know why that would be. Where does the 1 minus where does that 1 come from?
It comes from, so it comes from, let me just move all this down slightly. It comes from, and we did this, it was 750 plus 0.5 times Y minus, oh, there it is. Okay, I'm sorry. There, it's the T minus 1 minus TR. There it is. I didn't catch that. I apologize. So Y is still Y. T is still tau times Y minus 1. plus, why is that sign wrong? Sorry, let me go back and look at this from the previous one.
You're good.
Oh, yeah. Okay, so plus, this should be plus TR. And then the transfer was mu yn minus y. So actually we can get rid of all this down here. So that but it increases its tax revenue. So it should be plus 1 minus. Okay, sorry. That now it makes sense. Let me try to explain this here. The tax revenues are increased by 1. So t goes to t plus 1. So this was y minus t, but because you're adding 1 to it and you're doing it in parentheses.
The sign when it's distributed.
Yes. Okay, so there is kind of a small error in there, but in that one, there's a line that's got a small error in it. This one here should have a plus. It's fixed in the next line. In case you're looking at the notes again, this should be a plus, but it's fixed in the next line.
Okay.
So then this is where we can substitute in here. So t becomes tau times y, which is the same as before, minus 1 plus mu times yn, which is the same, minus y for the transfer payments.
Yeah.
Please take a look at that and just let me know if there's anything that's unclear.
Me. Okay, yeah, that makes sense.
Okay, so now just a lot of algebra here. Mu yn minus mu y, and then you can factor out a y from here, and here.
Yeah.
So you get y parentheses 1 minus tau minus mu, and that's where that minus 1, it just moves, minus 1 just pulls over with this one here.
C2 plus y minus 1. Got it. Okay.
And then from here, you can then substitute in the values. So this is all equal to C. So C is 750 plus 0.5. Y we don't know. 1 minus 0.25 minus 0.15 plus 0.15 times 1 million minus 1, like that. And then dot, some pretty heavy algebra here, but it ends up being 112,072.143.
Okay.
Sorry, that's not right. C equals, we need to do the C first, 75,749.5 plus 0.3 y. So what you'll notice is that $1, the only difference is right here. This was 75,750. It went down by half because of that 0.5 times that. So there might have been a shortcut to figuring that out if you do this stuff all the time.
Okay.
So then we go back to the whole y equals 7. Let me see, where did we do that?
The C, y equals C plus.
Yes, C plus I plus G. And interestingly, you do have to reuse the government, that G is now 2501. 75,749.5, 0.3 y plus I is still 200 minus 2r plus 2501.
Got it.
Now, rearranging terms, solving for y. Again, a lot of steps there, but we've done that once. Take a look at those notes if you have questions.
Yeah.
And then the multiplier is again the difference. So you're taking the old, or the new, the new, and subtracting the old. This equals,
and
so
is the one we calculated in the one above or in A, part A?
it looks like it is from part A. So part A.
Got it. Okay.
There. So then the summary here, which I think is maybe the part that you would have to summarize, is that for government, $1 increase in government spending and a $1 increase in tax revenue increases a Y by 0.714. So that was that. So this was the 2,500 to 2,501. And then the tax was the $1, T becomes T plus 1. The Y gets bigger.
Got it. Increases out. And that's any. Okay, cool. That makes enough sense.
Okay. So just looking ahead here, 5, I mean, I should have done these in a different order, but 6 is more like what we just did. 5 is more like 1 and 2. If there's a preference here for which one to do next.
Let me look. Wait, 4, what, sorry.
So
4 is
so
similar to?
4 is more like, I think, 1 and maybe 2, and then 5 is more like the one we just did here, 3. I'm sorry, 6 is more like 3. And then
Okay.
5 is something totally new, kind of. Although I think it's like 2.
Maybe let's try 4 and then 5.
Okay.
6, I feel like I can I'm pretty confident with, but 4 and 5 definitely could use, I think, more practice.
Got it. Okay, so all right, so here's exercise 4, and then the relevant second part here. Simple 2-period model. So I guess 2 scenarios here. So she can either go to college, which will cost $10,000, or take a job that pays $12,000. In the second period, she'll work, and earnings will depend on whether she went to college in the first period. Specifically, if she did not go to college, she will earn $12,000 again. But if she did, her earnings will be $10,000. So it's kind of it may overly complicated way of saying it costs minus 10,000 in the first period in option 1, but then you get $40,000 in the second period, or you can get 12,000 and 12,000 in each period. So they again, if you'd taken they do these 2 ways where it's like the minus 10,000 in year 1, and then in year 2, it would be up 40,000. And then in the other scenario, you're getting, 12,000 and then 12,000. So these arrows are meant to indicate what your positives and negatives. And then this is T, and this is all from finance, by the way.
Yeah.
So in terms of how to do this, you choose one option or the other. So let's do option 1, which is the college route. So in the college route, it's minus 10,000 plus the 40,000, and then you divide by this 1 plus R to the power of 1 for the because that it's like what is it in today's dollars? We talked about discounting that.
Oh, yes, I do remember this. Okay.
So you go to your calculator if you want, you got that, and you'll get 26,363.
Okay.
So in the first one really has the following. It really has this 1 plus 0.1, but it's to the power of 0. And that's why it's never written, if you're wondering about that, because anything 0 power is 1, so that doesn't contribute on the bottom.
Okay.
Option 2. So this was the college route. Option 2 is I'm going to get $12,000 in year 1, and I'm going to get $12,000 in year 2, but in the year 2 you have to discount it like that. And this ends up being 22,909 for not.
Isn't that the not going to college route?
Yeah,
Oh yeah. Sorry.
the second one, yeah.
Okay, let me. There's option 2, which is okay. So you take and so the 12,000 is what you're getting,
Yes.
meaning not a negative.
Right. She's
Wow,
paying the
the
10,000 to go to
cost.
school. She's receiving this for her income. These problems are always based on like what you are either paying or receiving.
Okay, and then where did we get the 0.1? Oh, because the interest rate is 10%.
Yes.
Okay, and that's 22. Got it.
Okay, part B is the same scenario with a different interest rate.
Okay.
So it's the same calculations, but with a new value of R. So R is now 0.3. So there's a very clear pattern here where your instructor changes like one thing and you go back and adjust. So in scenario 1, it's minus 10,000 in year 1, cost you, and then you get 40,000 over 1 plus 0.3 to the power of 1. The result of that is 20,769. Option number 2, the 12,000 that you get plus the 12,000 that you get, 1 plus 0.3 again. That ends up being 21,230. So this
So in
time
that case, it would be better to not go to college.
Yes. All right. Part C. This one actually is pretty fast. According to this model, people who go to college are inherently more patient. Explain why this is so. The answer here is based on really it's really based on the rate, which these aren't reasonable rates. Like there is no interest rates that high, but the idea is that, and you know this from what you've been doing, it's really these models, like you have to pay something to get something in return, whereas there's a guarantee now if you go to work, but there's a greater return if you go and put this investment in.
Yes.
Your time and money. So but these are typical scenarios. So almost every sort of business scenario is, I'm going to spend some amount of money, and in the years that I'm going to keep it, I'm going to get some sort of return. And so the idea here, but in terms of the R, we saw this as R increases, it's better to not go to college. As R decreases, better to go to college. So that this first one was going from 10% to 30%. That's why it was better to not go in that scenario.
Okay.
All right, so let's go to number number 5 here. There are two stocks under consideration, stock A and stock B. Information about them is given below. So stock A has a return -4%. That happens 25% of the time. You can think of this as X and P of X,
Okay.
2%, 56%. So sometimes these are like, they sometimes call them like bust, or bust is like the bad
Yeah.
scenario, average, great returns or whatever. So which would you buy if they cost the base? They're just asking part A, compute the expected value of X for A and compute the expected value of X for B.
So is this the same as like multiplying -0.04 times 0.25 plus?
Yes.
Okay.
Plus
I remember.
0.02.
And then for B, that's fine. Okay. That I understand.
Okay, so A is greater than B. So all other things being equal, you would choose A over
Yes.
B. But things are never equal, and that's where part B goes to. It says stock A pays dividends of $100 every 2 years and can be sold for $500 after 4 years. Okay, so but B pays no dividends but can be sold $906 after 4 years. Given that cost A costs $600 and stock B costs $800 today, which would you buy? Again, so
Okay.
for A again, like there's a cost, which is important. It's minus 600. Like you have to pay that today. I know actually it's interesting, the solution doesn't have this, but you get it's $100 plus you get $100 after the first 2 years. Okay, so but in terms of its current in terms of today's dollars, you have to discount it, and then you get another $100 after 4 years, but it's not worth as much as today's
And
dollars.
why is, so I understand like, oh, so it's just, oh, got it. Never mind. I was gonna ask why the 4, because why, but I understand it's not like it wouldn't be 2 again because you need to make that number bigger because it gets discounted each year. And so
Yeah,
after 4 years.
yeah, and these are important questions to be asking, because like it is kind of confusing. Like, why isn't it 2? It's because you're looking at it from today, but you get it in 2 years, but it's today's dollars.
Yeah.
The next thing is that you sell it. So you almost want to make a picture: buy, dividends, and then sell. So you get $500, but again, in today's dollars, what is that worth? So this ends up equaling -$15.68, which is bad.
Yeah, like we wouldn't want to do that.
Yeah. Now they do it, they say it differently. They show you that the present value, so the part, let me do it in red here. So they call this part the present value. And then they say that the present value is less than the purchase price, which is why you would not do it.
Okay.
But I think it's better to kind of look at it all together. You can decide that as well. For B, you are paying $800 today. So you're out that money. There's nothing on the bottom here because it's today. and then you're selling it in 4 years for 960, no dividends. There's a 4 there. And that ends up being minus 10.21 $10.21.
Got it. So you
And
wouldn't want to buy either of them.
yeah, and that's why the solution says that. Sometimes they throw in, in the finance class, they'd ask you, well, what would the dividend have to be so that you'd get some sort of return? But this is, I mean, it's a weird question because typically they do want you to choose one or the other, but not in this
Yeah.
case. I don't know.
Yeah.
Okay. All right. So we actually have plenty of time to do the last question here.
Let's just go for it.
Before we do that though, any questions, these cash flows, you're clearly going to get one if you're asking me. These are.
Yeah. I don't think so. Honestly, I think I understand these better than some other topics. So
Okay.
that seems to be good.
All right. This is back to kind of the nice questions to start out. So they give you they give you savings private. And I believe we started out by saying savings national equals savings private plus savings public. I believe that's an equation we used previously. Yeah. They give you I, they give you S private, and they tell you that budget deficit of 500. So your government is running budget deficit of 500. So that has to be incorporated into this.
Okay.
So this is where it's a little awkward for me, but they're saying that means that S public is minus 500.
Okay.
All right, so the I here is 3,400 minus 100R equals 2,500 plus 20R minus 500. Do you have any sort of review sessions before your test tomorrow?
Not like I have videos I need to watch, not with a person though.
Okay. This is one of those things I would like to know more about, but
yeah,
maybe it's clear to you. So now you're just solving for R. Okay, so you just move some things around. You end up, it's 2,000 on the left, on the right here, 2,000 plus 20R, 3,400 minus 100R. So move some things around here, 1,400 equals 120R. R ends up being 11.67%.
Cool.
That is the equilibrium interest rate. That is everything that they want for part A. The equilibrium or the investment level comes from using that value of R in the I equation. So I equals 3,400 minus 100R, 3,400 minus 100 times 11.67, which is whatever it is, 2,233.
That's easy enough. And then
part C, we got for part C. What is the level of private savings? Okay, so there are a couple ways to do this. You could put it into that private savings formula, or you can use the fact of the totals. The fact that like 2233 has to equal private savings minus 500. That's one way to do it. Or you can put it back into the savings private equation, which was 2,500.
Yeah, I feel like in a test, I would just put it back into the equation to make sure.
Yeah.
Everything checks out.
Both. All right, just give me a moment here. Okay, part D, what is the new equilibrium? So there you go, yet another question where they make a little adjustment here to something. Okay, so it says the deficit is changing, it's going to 600. So the new equation is 3,400 minus 100R equals 2,500 plus 20R, but instead of being minus 500, it's minus 600 now. And you're solving for R again. And then we need to make some sort of a statement here. So R ends up being 12.5. So the idea here is that if if the deficit, so the deficit, increases, goes from 500 to 600, R goes from 11.67 to 12.5. And then they do this graphically, but I think that's kind of a nice economics type of summaries to say what happens, like whether it goes up or down, so on and so on. So they graph these. And let me see here. So the graph is, so we've got savings going up, investment going down, and your rate is over here for whatever reason, just don't get, but that original rate was 11.67. They're saying that this S moves up, that new equation, causing the interest rate to also rise to 12.5.
Got it. And is the S, that's national savings or private?
Private.
It would be
I thought, so I was graphing the equation, this one right here.
But then how does it move without it being because if it includes the deficit, then isn't it private and public, so national?
It's a good question. Because if you subtract this, it would actually go lower. So I don't know.
So true.
Because it's like your question's great, because I like, it's showing, the solution shows that it goes up, but the math doesn't, like you just said, where does that come from? Well, for it to move up, this number, this intercept also has to go up. I'm sorry, I don't have a good answer for that. Maybe maybe you can send an email, get that answer.
Okay. Oh, maybe because it's inverse, because the rate is on.
That could also be, yeah.
So it is like if we graphed it where rate was on the other end,
that would do it.
Then the okay. Ooh, that makes sense.
Okay, suppose households, this is part E. Part E, suppose households believe, snip that in. Greater government borrowing today implies higher taxes in the future to pay off the government debt. That is, households expect a lower disposable income in the future. What does this belief do to private savings and the supply of loanable funds today?
Private savings would increase if they expect that. Wait, would it increase that greater government borrowing today? Oh yeah, because if they're expecting higher taxes in the future, I feel like then they would increase their savings now.
They're showing the answer as the movement back the other direction in the savings curve.
Got it.
Which, does that mean it increases? I mean, if we flip things, then it does.
Yes.
That would also cause the rate to go down.
Okay. Oh, that makes sense, because then you're moving it back basically to where it is. Clip that in.
All right, so what is the plan here for the next hour? Maybe
So I'm gonna send you a practice exam. I'll just email it.
Okay.
And we can just, I guess, start working on that. Yeah. But I'll do that and then
Do,
I can like,
do you have any study groups planned for tonight, or are you a solo studier?
I'm typically a solo studier, but I am gonna meet with a few friends tonight to just
Okay.
go over some things. So,
If you
yes,
can, I
I
mean,
will.
one, just if you don't mind, I would recommend you try to do the problems, like show them how to do them. That would be a great way to demonstrate your
Yes,
understanding. Because
yeah,
most time people don't want to jump in and do that, and that might be you tonight.
yes. No, I can definitely do that. That tends to help me a lot, actually. So, I will send that over to you and then I'll rejoin the thingy at 5. So,
Yes, yeah, that's good. Just grab that new booking link and join from there. But all right, I'll see you in about 10 minutes.
perfect.
Okay, see you. Bye.
Yeah.